I hope everybody enjoyed lunch okay. Our next panel is going to discuss critical concern to Western wildlife managers and ranchers, and that is livestock and wildlife disease management. And we've got a really good panel that's going to discuss this with us today. We have Kurt VerCauteren, Feral Swine and Ungulate Project Leader with the National Wildlife Research Center. We have Scott Talbott, and he's the director of our Wyoming Game and Fish Department. We have Dr. Michael Miller, Senior Wildlife Veterinarian, Colorado Department of Wildlife, and Dr. Camille Hopkins, Wildlife Disease Coordinator, Ecosystems Mission Area, USGS. Kurt, would you mind starting us off, please?
Sure, you bet. Well, thanks for having me here today. I'm with the National Wildlife Research Center, which is the wildlife research branch of USDA, APHIS, Wildlife Services. So all of our work is focused on human-wildlife conflicts of some sort. And a large focus of mine over the years has been the interaction, the interface between livestock and wildlife. And you see they've added feral swine to my title because we've kind of started doing less of that kind of work, or decreased focus. So I took on the feral swine stuff too, another invasive, so it kind of fit me. And I'm just a researcher too, so I just kind of lay out facts as they are, just a simple, here's what we found, here's what we found, here's what we learned. I want to kind of lay out the big picture some. We live in a huge, diverse continent with several different ecoregions, and when Eurasians showed up, we really modified these ecoregions in a big way, and that's had some really big implications relative to disease transmission. First of all, we brought a lot of the diseases with us. A lot of the diseases that are now considered endemic, they came over as we brought our livestock over and things. Bovine tuberculosis, brucellosis, rabies, pneumonias. Then we've also got several emerging and re-emerging diseases like CWD, West Nile, the different variants of avian influenza, plague. And there's always constant risk of infiltration of different foreign animal diseases that you hear about in the news sometimes. Like right now you're hearing about African swine fever, and that's something for us to really be paying attention to, what's happening over in Eurasia right now. Foot and mouth disease is another one that's always on my radar. I've always predicted that in my career I'll probably be dealing with foot and mouth disease, and now I'm kind of nervous about African swine fever also. The biosecurity that we have to try to prevent disease transmission between wildlife and livestock and vice versa, it goes both ways, right? It really kind of runs the gamut. And as I look to the western part of the country, that's where our biosecurity a lot of times is the lowest, just because of the nature of it, the size of our pastures, free-range grazing on public lands. There's not a lot of biosecurity in those kinds of situations, and how could there be, right? All the way to different parts of the country where we've got a lot of our poultry operations and our swine operations where the biosecurity is really, really high. So those need to be sort of considered relative to the situations. I think about how many road miles a lot of our livestock puts on. The immense number of cattle and swine that are on our highways every day is just phenomenal within our country, and then also imports. So we import a lot of cattle from Mexico and Canada, of course, for finishing, and then through all growth stages, just on our own highways. That's got a lot of implications for disease transmissions. And a lot of times once something can jump to the wildlife, how do you get it out is the issue. We often think of the big game species, and there's also the other species of wildlife that we need to be cognizant of, like the paradomestics, the raccoons, the other smaller mesopredators and things that use the same resources that are meant for livestock. I think that we need to talk some about, I don't get to be in front of folks who aren't just other researchers a lot of times, so when I get a chance, you got to bring up things like the need for collaborations, and there's some differing objectives of the differing agencies. Our wildlife management agencies, at the request of the hunters and needs of our publics, did a great job of bringing wildlife back. In a lot of cases, kind of from the brinks of what we really suppressed lice populations. Look at our white-tailed deer populations. About 30 million when Columbus first came, right? And by 1900, we're down to quite, very depressed deer populations. Same with our elk populations, bison, of course. We've done a good job of bringing those populations back. Sometimes maybe too good of a job because we also have all this livestock now. So we've got these ag agencies who have different perspectives and producers who have different perspectives. So what are the balance between those populations? That sort of thing needs to really be addressed. And we think of the health of our animals. For a while, and it seems to me it's kind of changed a little bit in recent years, but for a while, really in this One Health kick. I really like that, where wildlifers were at the table more. When I speak of One Health, I speak of human health, livestock health, and the health of the wildlife. And it seems that that's kind of gone away a little bit. I don't see the wildlife component being at the table as much as it was there for a little while. And it's just got to be because about 80% of the diseases that we're dealing with have some kind of a wildlife component. So it's always the elephant in the room. I think another point related to that would just be the need for cross-discipline collaborations. There's a lot of expertise in a room like this, and a lot of times we kind of all get siloed. And there's a big need for us to be working together and working on those common goals for those agencies. I think that some of these issues are kind of daunting and really quite scary, but as I look around, there's a lot of good global knowledge, kind of a lot of background. So I think that there is potential to as we move forward, for those of us in the trenches, that we'll be able to kind of inform decision makers, policymakers like yourselves, to help make good decisions as we relate to these issues. And that's what I've got to say for this point.
Well, thank you, Kurt. Next on our panel, we have Scott Talbott, and he's helped me understand a lot of wildlife-livestock disease interactions, just diseases in general, and so hopefully he can do the same for all of you today. Scott, would you please provide your remarks and insight?
Absolutely. Thank you, Doug, and thank you for the opportunity to be here today. I found it pretty interesting this morning in Governor Mead's opening comments when 3 of the 5 invasive species he talked about were diseases that directly affect our indigenous wildlife, and I think that he mentioned brucellosis plague and Whitenose Syndrome. I'd like to take a minute and visit about a few of those diseases. Chronic wasting disease, touch for a moment on brucellosis and pasturilla and bighorn sheep because of the implications not only for wildlife but for the livestock industry in Wyoming and other states. And certainly chronic wasting disease, well, at this point we are not concerned about transmissibility to livestock. There's been a lot of background studies and testing on that, and we have tested those hypotheses at our research facility up in the Sabile Canyon for almost 20 years and are fairly comfortable with that. But I would like to take a moment and talk about chronic wasting disease and that there's a lot of misunderstanding about that disease. It's caused by a normal folded protein. It's not a bacteria, it's not a virus, it's not a invasive or a foreign body into the animal that has that. And then once those proteins become folded, they become infectious and then cause a disease, a transmissible disease. It's referred to as a TSE, a transmissible spongiform encephalopathy. Most of you know those diseases from the outbreak of BSE or mad cow disease in the United Kingdom some years back. Chronic wasting disease only affects members of the cervid family, which are deer, elk, and moose in North America. It's currently found in about 25 states and 3 Canadian provinces, and recently it has been found in Norway and Finland. There's been very isolated cases of that in Korea as well. It's a long-term illness, and there are no clinical signs of that disease until very, very late in the history of the disease, and And then the symptoms are very similar to many other diseases that we see, such as EHD, blue tongue, and that. Many of the animals that are harvested by hunters that are positive for CWD have absolutely no outward symptoms and look completely normal. Transmission, we think, is largely through nose-to-nose contact, saliva, urine, feces from animal to animal. However, there is very compelling evidence and proof that there is environmental contamination as well. So once the prion, or that infectious protein, is spread into the environment, animals that inhabit those areas, specifically cervids, can pick up that disease from the environment as well. At this point, there is a very definite and strong species barrier, but we would also say that that is absolutely not an absolute barrier, and it appears that CWD is becoming more and more infectious. It's fairly new disease on the landscape as far as wildlife goes, and probably only been around since the 60s, identified in 1980, and the Wyoming Game and Fish Department had, in cooperation and consultation with Colorado Parks and Wildlife and others, has done a lot of research on this disease over the year. CWD does pose a growing threat to our deer and elk populations in Wyoming, and it has slowly moved across the state from the very southeast corner and is getting closer and closer to Yellowstone National Park and large concentrations of ungulates up there. Right now, there's no known way to control it or manage or eradicate this disease. There's no vaccine for it, but we're working on some proposals to start to manage that disease more as we move forward. I was just part of the Association of Fish and Wildlife Agencies in the adoption of 100-plus page best management practices on chronic wasting disease, and that obviously looks at the transportation of live cervids, not only by the captive cervid industry, but by state agencies, carcass disposal, proper carcass disposal, and disposal of those parts in a landfill. The Wyoming Game and Fish Department will be starting a very large public outreach process in the very near future to look at potential options and also a better public understanding of what we know about chronic wasting disease. Quickly on brucellosis. Brucellosis has been a long-term disease in the state of Wyoming since right after the turn of the 19th century. We have brucellosis in bison and elk populations in Yellowstone and northwest Wyoming. In 2003, as a result of an outbreak of brucellosis in domestic cattle, Governor Friedenthal put together the governor's brucellosis coordination team. Wyoming Game and Fish Department continues to be a very integral part of that, and we have a pretty extensive brucellosis testing program throughout the state. Not only do we test on our feed grounds and in the designated surveillance area established by the Wyoming Livestock Board, but also we surveil a quarter of the state every year through hunter harvest. We have recently seen a slight infection of brucellosis in the Bighorn Mountains. We contribute that somewhat to refugia of elk on private property. And elk have the ability, unlike about any other animal I'm aware of, to find places where they're not harassed, and large numbers of elk can find those areas fairly quickly. And the management of those elk is critical to the spread of brucellosis. Our feed ground program, we feed somewhere between 15 and 18,000 elk on state-operated feed grounds. We have implemented a number of practices to help manage that disease, but we continue to work very closely with livestock producers to prevent commingling whenever that is noticed during the high-risk period. Then just very quickly on pastorella and bighorn sheep, Governor Geringer actually asked the conservation organizations and the domestic sheep industry to sit down at the table many years ago. I think it's been about 16 years ago now. After a lot of hard work on everyone's part, they came to an agreement on looking at separation issues between bighorn sheep and domestic sheep, and that plan, we call it the Wyoming Plan, has been very successful in the state of Wyoming and was actually adopted into statute a few years ago. But we continue to sit down in a very collaborative manner with anyone who wants to sit at the table, and that includes wildlife enthusiasts, conservation groups, livestock producers, livestock organizations, and work through those issues on a state-wide level. And with that, I'll go ahead and wrap up.
Thank you, Scott. Next on our panel, we have Dr. Miller. Would you please give us your remarks?
Certainly. Thank you, Doug. I appreciate it. I appreciate the opportunity, the invitation to come. This is a new forum for me. And you all should thank us for not showing slides of the things we do after lunch. So, I'm a practicing wildlife veterinarian, and I honestly, many days feel like I don't do my job very well, because I see my job as helping the state of Colorado specifically, and all of our western neighbors and our neighbors in other parts of the country, to either prevent wildlife disease problems, or when they occur, to pretty immediately do something about them and bring them to a point where they're of little or no consequence in the big scheme of things. And that just has turned out to be really hard to do. On the upside, business in the wildlife disease world is really, really good these days. So job security, I think, is quite high for those of us who work in this realm. I was really struck by the commonality. I mean, this panel looks sort of like that Sesame Street game, which one of these things is not like the others if you look at the whole agenda. But what we're really talking about are a bunch of invasive species that are just really, really small. They're very tiny things, but they're essentially the same features that we've been talking about with invasive plants, and that you're going to be talking about tomorrow with respect to recovering and trying to mitigate the effects of these things. These things are inadvertently introduced. The diseases that we worry about in wildlife in the West are really things that weren't part of the native ecosystem. Direct and then many times collateral impacts of these things, they're pretty darned intractable once they get established in the wild. And certainly preventing them from becoming established is far easier, at least from a technical standpoint, although maybe not as easy from a practical standpoint. There are both biological and socio-political facets to these things, as Scott alluded to, and there's lots of challenges, and in many cases the socio-political challenges are actually more daunting than the biological and technical things. There are, though, some really tangible opportunities for regional approaches and for some progress to be made. And the West has led in the arena of wildlife disease, actually, the way it has led in many other of these important wildlife and conservation management issues. And another thing that strikes me is that this is another case where many times states are sort of left up to clean up the messes that we've sort of inherited with these problems. In terms of the impacts and the implications, the diseases that we're talking about have more immediate and maybe more tangible effects on wildlife, sickness and death at the minimum, at least the ones we worry about. In some cases, diminished abundance, and then at the extreme, diseases like plague are resulting in imperilment not just of directly affected species, but of indirectly affected species, and in some cases of entire grassland and shrub steppe ecosystems. For livestock, in most cases, at least the diseases, the short list that we're talking about are the impacts are more indirect, although some of the foreign diseases, the diseases that aren't currently in the U.S., were they to become established here or brought in, could have some pretty serious impacts directly on morbidity, mortality, so sickness and death losses in domestic livestock. Avian influenza is a good example of a disease that actually does kill lots of domestic birds when it gets in. But probably more common are these indirect effects, and anything from production loss, like you would see with brucellosis, to pretty severe, in some cases, limits on market and trade opportunities, both within the state, interstate, and in some cases international. And sometimes it's not only the reality of these things, but the perception of what might be a threat or what might be someplace and not someplace else that someone's trying to keep out. There are some common challenges. There are technical and technological gaps. Our resources are limited, same as all these other things. We do have, I think, some ways that we could approach this that are pretty tangible and in some cases practical, but they're really easier said than done in many cases. And as was pointed out with some of the issues earlier, these just aren't things that are amenable to quick fixes. We do need sustained and sustainable approaches. There are some good opportunities. There's some examples of multi-jurisdictional adaptive approaches that have been taken and are being taken. The Western Association of Fish and Wildlife Agencies has some good recommendations, and we're making progress on wasting disease control, both prospectively and retrospectively. And then the work that's been done recently on plague is another good example. There's an opportunity for some kind of interesting cross-cutting technological advances in the realm of vector vaccines and novel vaccine delivery approaches. Somebody was talking about a fairly low-tech approach for seed plant production or propagation earlier. We actually use a fish bait making machine that costs about $2,000 a piece rather than the $50,000 to $100,000 larger production machine to make the vaccine baits that we use to deliver or to produce vaccine baits for plague control. There are some science needs, but the science we really need is more applied and really should be directed toward critical gaps in our understanding in our tools as they relate to disease control. And I think we'd be better served in the West if a lot of these efforts were state-led or at least state-guided, with an emphasis on control and prevention rather than just learning interesting things about these problems. We need support, both fiscal and sociopolitically, and that really ought to be directed primarily toward these state-led or state-guided efforts. And then finally, and this is echoed from some of the earlier panels, we need these things to be sustained and sustainable, hopefully directed toward state-led efforts.
Thank you, Dr. Miller. Dr. Hopkins, could you please provide your... Yeah, the podium went away, so I can hold the microphone for you.
No, it's all right. So good afternoon. USGS, led by Director Jim Riley, provides science for a changing world through the mission areas that I have shown on this slide. In the ecosystems mission area, led by Associate Director Ann Kinsinger, we provide science to support management of species, land and water, and biological threats. And for us, biological threats include invasive species and disease. While our mission is to support disease management on DOI lands, we know that diseases don't recognize jurisdictional boundaries, so we partner a lot with all of you, with states. I'm a wildlife veterinarian and disease ecologist, and as wildlife disease coordinator at USGS, I oversee our national aquatic and terrestrial wildlife disease portfolio. Out of our 16 federal science centers, we have 2 primary centers focused on disease, our National Wildlife Health Center in Madison, Wisconsin, and our Western Fisheries Research Center in Seattle, Washington. But we also have disease researchers embedded across the nation, including here in the West. We have disease researchers in Alaska, Hawaii, California, Oregon, Washington, Montana, Colorado, and North Dakota, dealing with some of the issues that we're talking about today. We also have research at our cooperative disease research at our cooperative research units located at land-grant universities. So as we've seen on previous panels, we have partnerships with academia. I want to point out, and this has been mentioned by the panel, the link between wildlife disease and invasive species. As has been discussed, many of our diseases that we're talking about are invasive, non-native, like brucellosis, plague, Whitenose syndrome, but invasive species themselves can also play a role in spreading wildlife disease. Certainly Kurt is aware of that in terms of feral swine and the USDA program nationally to deal with them, but we also have non-native vectors like the Asian tiger mosquito that can spread diseases and the newly recognized Asian longhorn tick, which even though we're monitoring it in the east, we don't know if it's here out west, and if it is out west, how it's going to affect not only livestock, but also our cervid populations. Because of this connection, I chair the Federal Interagency Committee on Invasive Terrestrial Animals and Pathogens, and our goal federally is to promote information sharing and collaboration related to these issues. Now today I want to leave you with 5 key points related to our discussion. First, understanding the ecology of wildlife disease is really and understanding the landscape level impacts of disease are important for us to better understand how to target our disease surveillance and how to manage these diseases. Good example, which has been hinted at today, is there was a great partnership between USGS, Fish and Wildlife Service, Park Service, USDA, states of Montana, Wyoming, and Idaho to look at brucellosis. And it was just a few years ago through genomic work that it was determined that elk are a primary source of livestock infections and self-sustaining brucellosis reservoir. That has led to additional work looking at elk migratory movements, connectivity, and how that can impact the spread of diseases like brucellosis. And that's a partnership with Wyoming. There's been a report, but we expect a scientific publication probably in the next year on that. The second point is the development of early detection tools using advanced technology can really promote effective early response to disease. Whether it's creating online resources for managers, our scientists at the National Wildlife Health Center have worked with Park Service and state partners to develop a chronic wasting disease online tool for surveillance in white-tailed deer. But we also have new molecular tools that we're using, and I'm going to highlight a few from the aquatic side. A few years back, we saw, unfortunately, the outbreak of proliferative kidney disease, thousands of whitefish dying along the Yellowstone River. Our scientists are working on environmental early detection tools and refining molecular techniques so we can predict or detect early the next occurrence of that disease. Our scientists are also working on some innovative early detection tools for Asian fish tapeworm, an exotic or invasive species that's impacted listed fish like the humpback chub. My third point is, as has been said throughout the day, coordination and collaboration are what we need to enhance our interjurisdictional ability to manage disease. I think certainly, and I have a colleague in my office, Steve Hanser, who works on sage grouse and sagebrush ecosystems. I think we can look to that as an example of coordination and collaboration that has worked, as well as USDA has done an excellent job leading federal and state agencies in avian influenza surveillance. And those are some good examples of that. My fourth point is surveillance. We really need it at the regional and national level, and this was sort of hinted at in some of the discussion earlier today, to promote a proactive response for diseases that are occurring maybe not in your jurisdiction, but nearby and they're on the horizon. Good examples of that, Fish and Wildlife Service has led a national effort for Whitenose Syndrome, and USGS maintains these Whitenose Syndrome spread maps. Also, we have a new effort at USGS, our National Wildlife Health Center. It's an online tool called Whispers. And the goal is it allows you to look at a map of the U.S., see what the current disease outbreaks are that are being investigated in wildlife across the nation, but it also has 40 years of data in there as well that you can look into. And it's not just USGS. Our scientists are partnering with other diagnostic labs like the University of Georgia's Southeastern Cooperative Wildlife Disease Study. My fifth point is there are opportunities to grow. Two things I would pose to the group is USGS would love to work with states on horizon scanning for invasive pathogen threats, like those already mentioned by my fellow panelists, African swine fever, foot and mouth disease, and others. Secondly, we need a more coordinated rapid response capability for invasive pathogens. I have a collateral duty with FEMA, so I think a lot also about the incident command system, which obviously has been used for other invasive species, how we could work together to create a rapid response for wildlife diseases. And I want to close with a couple of points. First, I want to acknowledge I'm here representing the Science Bureau of the Department of the Interior, but I know on the ground you're working with our management bureaus, Fish and Wildlife Service, Park Service, BLM, Bureau of Indian Affairs. Many folks are here in the room or watching on the live cast. And we maintain a group, the DOI One Health Group, where together we keep in touch on these disease issues. The second point on my slide, I've got my contact information. I'm a coordinator, so if you heard about something today and you want more information about who the scientists are that are working in your state or how USGS can help you, please feel free to reach out. And the last point, the National Invasive Species Council, their Invasive Species Advisory Committee developed a white paper looking at reducing the risk for invasive pathogens in wildlife health. And they have a lot of good recommendations. In fact, some of them, Ungulate syndrome is a fungal disease of bats. It was first detected in New York and has since spread across the United States. It's been detected here out west. First detection was actually in Washington State. We have a lot of surveillance efforts going on in probably most of your states to look at the bat community to see if Whitenose syndrome is there, and also efforts to understand the microbiome, the normal bacterial and fungal flora and fauna on bat skin. Is any of that able to protect Western bats from Whitenose syndrome? And this, unfortunately, is a lethal disease. It typically affects hibernating bats. So in the east, obviously cave bats, but we're seeing it here out west. Sadly, we've lost about 6 million bats to Whitenose syndrome.
Thank you. That clears it up for me a little bit, hopefully for maybe some others too. I'm ignorant. To start off the moderated discussion, going back a little bit to chronic wasting disease, Scott, given the difficulty in containing CWD, what in your opinion is the best strategy for addressing the threat it presents? I mean, should we be looking at trying to control spread or just managing populations once they experience?
Thanks, Doug. Certainly, I think that initially trying to control spread, and we've done a lot of movement and migration work in Wyoming, looking at mule deer migrations, elk migrations in and out of northwestern Wyoming, specifically the Yellowstone ecosystem, but most folks in Wyoming are familiar with the work that was done on red desert to Hoback that shows that many of our big game populations in Wyoming are highly migratory. So keeping that in mind, there's probably a pretty good avenue for spread of that disease there. What we can do is certainly limit, whether it be in Wyoming it would be agency movement of deer or elk, what have you, and we have had an internal policy for a number of years that elk that come to our research facility or deer that come to our research facility, they don't leave those facilities. And so obviously with chronic wasting disease in southeast Wyoming and brucellosis in northwest Wyoming, we don't move animals around. And so that would be one step. Carcass transportation, moving hunter-harvested carcasses from one portion of the state that has CWD to other portions that don't, and ensuring proper disposal. Those are certainly things that we can start with right now. And our staff has been working very closely with the Western Association of Fish and Wildlife Agencies and the staff of Colorado Parks and Wildlife, looking at some parameters that we can explore to see if there's some things that we can do with the management of specifically deer populations to control or suppress the prevalence of chronic wasting disease.
Can you talk a little bit about the persistence of that prion in the environment?
I might actually ask Dr. Miller to step in on this, but because it is a protein, it's not a bacteria, it's not a virus, it can persist in the environment for long periods of time. I believe that scientifically they have proven that it can exist in the environment, and obviously different soil types and those types of things have an effect on it for a minimum of up to 16 years. But how long it can stay in the environment, I'm not sure that anybody knows at this time. I can tell you that there has been several attempts to sterilize facilities and locations that have had chronic wasting disease, and to date, I don't think that any of those have been successful.
Do you have anything to add to that, Dr. Miller?
These agents, not just chronic wasting disease, but the scrapie agent, a similar prion agent of sheep, persist for a long time, probably on the order of decades. And unfortunately, a lot of the soils that we have out west probably lend themselves to environmental persistence, maybe more than in other parts of the U.S. or other parts of North America. Clay soils and soils fairly low in organic matter would tend to be really good mediums for this stuff to persist. So yeah, unfortunately, once it gets in a system, it's going to be there for a while. When we do try to manage the disease, at least we can keep from adding more infectivity to the mix, and that's the idea, is we're really realistically not trying to get rid of this disease in the places that it's become established, but I think there's a long way that we could go toward keeping it under control, minimizing the effects on wildlife, and then also minimizing the potential collateral effects on livestock and ag operations.
Thank you.
Doug, can I add one thing as well?
Absolutely.
So I agree the environmental prion contamination is definitely a challenge. USGS has partnered with USDA and others to look not only at the prion in, let's say, in the soil, but also the fact that we now understand that wild rodents are able to uptake prion proteins as well as plants. So we have ongoing research to understand the implications of those findings, but I think it really points to, and Mike talked about this earlier, the kind of having an adaptive, and this has been mentioned before, an adaptive management approach to this. In other words, you've got to continue to monitor, continue surveillance efforts, and really also there's been a lot of effort to understand as well the impact of CWD on the abundance of various cervid populations. So we have a partnership right now with National Park Service at Wind Cave National Park, looking at different management strategies for CWD, and to see if we can at least manage the population so they aren't declining as they're dealing with this disease.
I'm going to shift gears a little bit with this next question, and I'm a little outnumbered up here, but I'm going to ask the question anyway. What is the best way to increase communication and collaboration between those of you managing wildlife and those of us managing domestic livestock?
Doug, I'll take a shot at that, and I think that the Wyoming Bighorn Sheep, Domestic Sheep Working Group is an excellent example of how all the interest groups sit down at the table, look at tough issues, have candid conversations, and work together for the betterment of all of those. And I think that, you know, as time intensive and as much effort as that takes, that's the only way that we get through these issues. I think the governor's brucellosis coordination team is another such effort where all interests have an opportunity to sit at the table, public meetings, and take public comment and engage the public and engage all the potentially affected interests.
Yeah, and you know, kind of as your counterpart on the domestic livestock side of the equation, I would say from my experience, being able to kind of rally around some of these wildlife livestock disease issues allows us an opportunity from a game management standpoint back to the agricultural sector, more opportunities to communicate, which expand beyond just disease issues as well. I mean, we work together on a lot of invasive species issues like we've talked about this morning already, but these disease issues, it's a lot easier to identify an objective typically. You know, it's one of those things that's beneficial across the board for both entities, and so it's been a good experience both on the brucellosis coordination team standpoint and the bighorn sheep, domestic sheep interaction working group. So I appreciate that.
I'd add a little bit to that related to CWD. Like Scott mentioned, CWD is not a disease of mainstream livestock, but it is of captive cervids, captive deer and elk. And a lot of times it's kind of contentious between us wildlife types and the captive cervid farmer types because we can point fingers at each other. In Nebraska, for example, it's pretty clear that it was a captive cervid outfit that there was spread from that guy's property off into the wildlife. There's probably other places where it could went the other direction, where it might have been from the outside of the fence looking in. And it seems if we just get at the same table, there are enough commonalities, everybody cares about their deer, right? That we can work together. And I've got some instances where I've worked with high fence folks to allow me to do research on their properties that was translational to the bigger picture, to outside of the fences. For example, a lot of our initial work with some live tests for CWD was all done on private infected captive cervid herds. There's currently work going on. Some of these, once these places are infected, like Mike mentioned, it doesn't go away. So some of that work that Camille mentioned about looking in rodents and things, we've got some research going on these high fence places that, well, they might as well try to get some good out of their bad luck in getting CWD. So I think just being at the same table, working towards those common goals goes a long way.
And I had one other thing to add, a couple of things, and so Kurt, you mentioned this earlier, One Health. So at the federal level, CDC, USDA, and the Department of the Interior have been working to really enhance our partnerships from a One Health perspective. So I think that's a great way also at the regional level to bring together different agencies on some of these diseases, for example, brucellosis, which and plague, which can affect humans in addition to domestics and wildlife. The other thing, again, flipping to some FEMA-related examples, actually USDA did a great job earlier this year holding a training exercise for foot and mouth disease, and I know they worked with states on that, so it was at the national level. I think having those kinds of training exercises for a foreign animal or invasive pathogen that we're concerned about helps because it, number one, identifies communication or coordination gaps. You know, when you're in a training exercise, who isn't at the table that should be there. But also at the end of the day, you can then come out with action items for how to improve response, to identify scientific gaps or opportunities to work together on things, for example, regulatory issues, like emergency exemptions or categorical exclusions, which from another disease standpoint, we have a North American effort, Canada, Mexico, and the US, looking at B-cell. This is an amphibian chytrid fungus, similar to BD, if you've heard of that, but this one was identified in Europe. It killed 90% of populations of their salamanders. The US has the highest global diversity of salamanders, so we're concerned about that coming here. But what we've done is we've been very proactive with workshops and exercises to kind of identify what are the gaps and to enhance coordination. So it's just a couple of points I wanted to mention.
Not to belabor this, but I think another example that might be one for the Western Governors Association to look at and maybe even think about as a model moving forward is some of the work that's being done on plague and black-footed ferret recovery, the incentive programs that are a real cornerstone of trying to protect a species that most agricultural folks really don't care so much for, which is prairie dogs, for the sake of being able to stabilize some of these systems to the point where ferrets can persist. And there's lots of secondary beneficiaries to that. But I think one of the things that's missing in a gap that I think is needing to be filled is maybe understanding better how to incentivize some of these approaches. It's easy to say do this to keep bad things from happening, but I think we need to be more creative than that, quite honestly. And again, this ferret plague model might be one to take a look at moving forward. That one I think is all ready to go. It's simply for lack of the financial underpinnings to really get it off the ground.
Thank you. Again, to change gears on you a little bit, we had a discussion with the last panel about emerging technologies. What do you think your science is going to look like in 20 years? And can you identify any new and emerging technologies that you think will be game changers as we try to manage all these wildlife-livestock disease interactions?
One of the areas that I'm been working on, and it's actually had multiple applications in plague. It's being applied right now in Whitenose Syndrome. We've looked at it a little bit for bighorn respiratory disease, and that's some of these vectored vaccines. So they're actually viruses that are engineered to produce the key proteins that might be required in an immune response that protects an animal from a particular pathogen. And so that whole arena is one that I think has some potential, particularly if you think about responding to new introduced problems that we may not really have the infrastructure for, but being able to put together pieces of technology that are already developed and pretty well established, so we understand, for example, that these viruses are not going to cause damage to the species that we're trying to protect, and yet could be modified very slightly to be beneficial. And I think some of the areas of vaccine delivery also they're going to advance pretty rapidly. Molecular diagnostics, and you alluded to that a little bit earlier, and the ability to pick up some of these agents in fairly low quantities in maybe unconventional media is another one that might help us a little bit.
Others right in line with that include environmental DNA, as well as volatile organic compounds are a way where you can detect things. So to some of Mike's earlier points, especially with diseases like chronic wasting disease, where we're sampling in very low numbers, it's hard to keep track of spread if you're not looking, especially if prevalence rates are very low. And it's hard to keep track of what those prevalence rates are. So new technologies to be used to do those two things, do like proper surveillance, are really important. Things like eDNA, we're using it in some applications where we can tell if a species has been in an area, and then even beyond that, we can tell if a disease, if a pathogen is in the area. And volatile organic compounds, what that is, it's we can get these signals from breath and from feces, and it's working for bovine tuberculosis, and we thought we'd try it on chronic wasting disease, and Scott pointed out how different chronic wasting disease is than a virus or a bacteria, and I'll be damned if it didn't work there too. So there are some new emerging technologies that have great potential.
Thank you.
And I just had one last thing to add. I agree, molecular genomic techniques, but also I think our data management is going to improve in such a way that we can harness all the metadata that we have to get a clearer picture of the spread of disease, the risk of disease, and hopefully move closer towards modeling or forecasting disease spread.
Thank you. Do we have any questions out there for this panel? I'm sure there's some. I had several.
Yes, my name's Mike Harrington. I serve as Executive Director of the Western Association of Agricultural Experiment Station Directors. So I'm interested in all of what you had to say, and this question is directed at Camille. And you said something about evidence for prions being taken up by plants, and would you elaborate on that a little bit?
Sure. So the studies, several of them in partnership with USDA, we have basically found that if you have prions in the environment, that plants are able to uptake those prions internally. And the most recent studies, which are ongoing, have looked at if you have prion-infected plants, can rodents that feed on those plants pick up the prion from them? So that's the next step that we're trying to understand. This project with USDA, I don't recall the exact plant species, but I know that they've looked at crop plants in this work. So more to come on that. This is still ongoing.
I'm Danielle Bykey with the National Park Service's Wildlife Health Branch and Office of Public Health. There's a lot of really exciting and promising technologies mentioned, whether it be GMO mosquitoes or even just vaccine vectored or virus vectored vaccine delivery systems. And then oftentimes in these situations, regulatory hurdles are limiting the application and use of these technologies. I think the 19J and different incentive programs that the black-footed ferret community has utilized and pioneered do have applications for other systems and other questions and problems, particularly related to invasive animals and the wildlife disease scenarios that we face. Do you see a role for the Western Governors Association or for more of these collaborative partnerships in eliminating some of these regulatory hurdles that are hampering application and more of that applied research that has been alluded to in other panels?
I think, yes, I think that there's a role, I think on several fronts, but I think that there's been some good progress made. The plague vaccine that is being used in the field is really only the second vaccine that has been allowed by USDA Centers for Veterinary Biologics, and it took far less time to get that into the field in an acceptable form than the first vaccine, which was one of the oral rabies vaccines. And so I think that there's actually a lot of open-mindedness toward maybe modifying, not compromising, but at least modifying the regulatory framework, at least for some federal agencies, to allow broader use of these kinds of tools in the field. One of the challenges is that in some cases with respect to licensing, for example, with a vaccine, the markets simply aren't there for allowing a company to invest and get returns on an investment for full licensing of, say, a vaccine for plague. And so looking for a way to make those things available to wildlife managers and make it sufficiently sustainable and economically reasonable for a private partner to cooperate and participate in is, I think, going to be a challenge. And again, that is a place certainly where the Western Governors Association and any number of other groups, I think, could help along those ways. And then streamlining some of the NEPA rules on this, and we don't have time to get me started on that, so I'll just leave it at that. Thank you.
Other questions? No? Oh, we have one over here.
Thank you. Garth Fuller with the Nature Conservancy. It's a question probably for Dr. Hopkins, but all of the panel. I know there's been quite a bit of study looking at what makes an ecosystem vulnerable to an invasive species for, so you can do some forecasting and predicting about where to be on the lookout for early detection, rapid response, or you could start expecting what could happen if an invasive species arrives. And I'm just curious how that plays out in your world with pests and pathogens as well, because I think it is interrelated. As an ecosystem becomes stressed or a population becomes stressed, they become more vulnerable. I'm just curious if you had any reflections on that.
So thanks for the question. The first thing that comes to mind is some of our scientists work on plague. At our Fort Collins Science Center, in addition to the work that our scientists had done on the plague vaccine, they've also looked at the other aspects of plague management, which is dusting prairie dog burrows to kill fleas and decrease the flea burden there. And our scientists have been looking at what are the environmental factors associated with increased prevalence of plague, not only causing the obvious outbreaks in prairie dogs, but with flea populations, what environmental factors might lead to them increasing and potentially increasing the spread of the pathogen. Along the same lines, we have some work looking at weather, climatic changes, and how that might affect the risk for plague. I need a moment to think of it.
I guess one of the things that strikes me about a lot of these pathogens that have co-evolved in systems outside North America is that when they are brought in across the board, our native species are quite vulnerable to them. And I think certainly the other environmental challenges and compromises don't help, but I think innately they're just very vulnerable to a lot of these things. Bighorn sheep is actually a good example. Wild sheep evolved from a species that originated in the Mediterranean, Eurasian area, those mountainous areas, and it spread as a group of species, a continuum. So it would be eastward, and eventually crossed the Bering Bridge and then colonized North America. Domestication occurred in the Mediterranean. The pathogens that co-evolved with domesticated sheep evolved in essentially the most extreme, globally, the most extreme polar opposite of where North American wild sheep evolved. And it's not surprising that when the host and the pathogen came back together in the western U.S., that you had a very well-adapted pathogen and a very, very poorly adapted host species in terms of the kind of selection for resistance. And I think that kind of a pattern repeats over and over again. That's probably a lot of what underlies Whitenose Syndrome. So I think while we should do everything we can, obviously, to keep these systems intact and restore them, in some cases, these invasive pathogens really aren't going to care a whole lot about how robust those systems are. And that really emphasizes the need to just keep them out to begin with.
Well, that was very interesting. I learned quite a bit from this panel this afternoon, and I appreciate it very much. Thank you.